What if the future of fueling up looks like a hydrogen fill-up that takes 20 to 30 minutes, yet the vehicle's only tailpipe emission is water vapor? Welcome to Industry Ignited, the podcast where we spotlight the leaders, technologies, and bold decisions transforming industrial markets and the built world. I'm your host, Dr. Leeanne Aguilar, and today I'm joined by Salim Rahemtulla, President and CEO of PowerTap Hydrogen Fuel Corp. Salim, welcome to Industry Ignited.
Thanks for having me, Leanne. I'm glad to be here.
Yeah, well, let's dive in. I know we've got a lot to talk about today. Now, you started in real estate development, then shifted toward energy and government-related work. What was the turning point that pulled you into clean energy infrastructure?
So it was driven primarily by the downturn in real estate. My focus was real estate development, but where I switched was an area where land use is really important as well, and that's renewable energy. Happens to be the other RE, real estate to renewable energy. So that was really the driving turning point. But it really has a lot of similarities to real estate development in terms of the background requirements for putting a land use in place. In this case, renewable energy gasification was my starting point. But again, the principles apply.
Okay, that's interesting. I hadn't thought about that before, but that makes sense. Yeah, you're still working with the land, you're still working with the permitting and policy around that. So now you mentioned early work around gasification projects for military energy independence. How did that experience shape the way you think about resilience, infrastructure, and national scale energy needs?
It actually put me, I would say maybe ahead of the game to some degree, because the exact issues that military installations have in terms of having resilience, the ability to withstand any sort of change that occurs in the nation, an attack, some sort of EMP, an electromagnetic pulse, something where there's a requirement for you to be independent from the grid. And I think that resilience that the military was looking for back then applies to the exactly how our energy system should be today. There should be resilience. For example, when we have a data center, if there isn't a backup power for an extended outage, then that's a significant problem that's going to impact how people can use their internet connections and so on. Then if it's a business operating, that data center is really a critical piece. Resilience is really important in that kind of an arrangement. And that, again, should apply across the infrastructure spectrum.
Yeah. Now, your career seems built on connecting the dots, like technology, capital, sites, and stakeholders. How did you develop that builder's skill set of aligning multiple parties to get complex projects across the finish line?
So some of that is inborn to some degree. It might be trained as well. I find myself to be a facilitator. And so part of what you realize is there are multiple parties, there are different personalities, and to bring them all together, you really do need to have a facilitation mindset. And then there are other aspects to it where a relationship development is really important. So, for example, aligning the constituents with the policymaker and the project's requirements. That requires facilitation, collaboration, working between the different parties to understand where the alignment points are, and then bringing those together. And that really applies across the board. I mean, obviously, you need to understand your technology, you need to understand how it works so that you can communicate it to the different constituents and stakeholders and align those parties. And it requires some flexibility, for sure, creativity and flexibility.
Okay, so yeah, just breaking down the complexity by getting that alignment and then really understanding the different parts. So you're simplifying it, really to, yeah. Now you've navigated challenging cycles like the 2007 to 2009 market volatility and other shifts. What did those cycles teach you about timing, risk, and staying in the arena?
A lot of what you have to be focused on, I think, is what really drives you as an individual. And so I found out early on that the manipulation of land use, the appropriate application of land use that's compatible with its surroundings, that was really where my strength was, where my mindset was, where my passion was. And I think that's sort of number one. And that helps you in managing the timing, the risk, and all sorts of other issues that might come along the way. that might deter you from whatever it is that you need to focus on. The 2007 to 2009 market volatility and downturn was a really important time frame in order to make sure that you focus on what it is that, and I guess, again, I'm talking personally, what I needed to do to focus on my continuation of where my passion lied.
Mm-hmm.
Uh,
So
Um,
was it during that time that you went from the one RE to the other, from the real estate
that's
to
exactly
the,
when that
yeah,
happened.
renewable
Exactly
energy?
right.
Okay.
And
And so you
so
saw an
it's
opportunity in there.
absolutely. And I think that this is where I honed my stick-to-itiveness, I'll call it. And that's something that's a really important skill or characteristic, especially in when you're starting a new business or starting a new effort. It's really staying with it. And yes, there'll be some tough times, some hard parts, but you got to work through those. And again, the focus gets back to what is it that drives you as an individual?
Right.
Um,
Yeah, stick to itness. I like that.
yeah.
For the person listening who's curious but skeptical, what's the clearest explanation of how a fuel cell electric vehicle uses hydrogen and why the output is only water vapor?
Yeah, so I remember that when we were having the pre-discussion for this podcast, I struggled a bit to try and explain it to you, right? It's such a basic perspective, but a lot of people don't follow the technical aspect of it, right? So in essence, you're using hydrogen instead of a battery. And the way the hydrogen works in this case is that you pipe the hydrogen through the fuel cell and it separates the electrons from the protons. And in any case, what happens is those electrons join up with the oxygen that comes into the system and it creates water vapor. And in that process, you're producing electricity to propel the vehicle. So there's an electric motor associated as well. So it works very similar to a battery electric vehicle, but instead of a battery, you have hydrogen and a fuel cell.
So interesting. Yeah, so very clean process. Yeah.
Right.
And so the output is just water vapor. Now, you highlighted the operational gap with battery electric in certain use cases like long haul, heavy duty, and material handling. Where do you believe hydrogen is the best fit and where is it not the right tool?
Very interesting. Right now, the way that hydrogen fuel cell electric vehicles are being applied is for light duty vehicles. And it's not entirely necessarily the most appropriate approach for you to do it with light duty vehicles. Where it makes most sense is if there is, for example, um, you're an Uber driver. Then a hydrogen fuel cell electric vehicle makes sense if you've got a lot of rides over a period of 8 to 10 hours, for example. Then you might be concerned about range. But with a hydrogen fuel cell electric vehicle, you don't have to worry about range because the fill up time is the same as it would be for a petrol or a diesel vehicle, 3 to 5 minutes. Three to
Oh,
five
okay.
minutes if you're doing a light duty vehicle, and with a heavy duty vehicle, it's 20 to 30 minutes. But where it makes the most sense is in long haul, heavy duty transport because the issue is range. And the other issue is, of course, the weight that you need to carry. If it's offset by a heavy battery, then there's less that you can carry. And that's one of the most important things with long haul, heavy duty transport is transporting material, equipment, products a long distance.
Hmm.
And so that's where it kind of makes the most sense. I think the other area is in transit and buses, especially when you're in an area which has remoteness to it and your buses need to make a lot of stops and go long distances. But even if it's a lot of stops, that makes a lot of sense as well because the hydrogen fuel cell electric buses enable you to have these heavy duty cycles. So I think
Interesting.
that's where it makes the most sense. And material handling is another area where you don't want to have a forklift having to charge for 8 hours all of a sudden, or 6 hours for that matter, in the middle of the day.
Hmm.
With hydrogen vehicles, you can keep those forklifts moving pretty consistently and constantly.
Now, you mentioned range, especially with the heavy transport vehicles. What does the range of a hydrogen vehicle, how does it compare to like a traditional fuel
So it's
vehicle?
very comparable to petrol and diesel vehicles. So I say gas, but ever since I've been dealing with hydrogen, I differentiate by saying petrol instead of gas because, well, it's hydrogen gas or
That's true.
gas,
Good
gas,
point.
gas
It's
you
still a
put into the
gas.
car. So
Yeah.
so I reverted to the English term petrol, but it's very similar. So, for example, if you were to fill up with 6 or 7 kilograms of hydrogen in your light duty vehicle, which means a Toyota Mirai or a Hyundai Nexo, then that would take you in the range of about 400 or so miles. It depends on how you drive, of course, but say 350 to 400 miles, uh,
Okay.
which is again comparable to a petrol vehicle. With a diesel vehicle, we're talking like a heavy duty truck, for example, then a fill up of maybe 70 kilograms would take you a distance of 600 kilometers, for example, or it's like 400 miles, 350 or 400 miles. And there are vehicles that have tested much further distances, 1,000 kilometers for that matter.
Oh, wow. Yeah. And how do they compare then to like electric vehicles? They sound like it's more
Yeah.
efficient than electric, and not only more efficient, but it's a lot quicker to fuel for what I'm
Yeah, I
hearing.
mean, just because of the range issues, your ranges are less. I mean, again, with a light duty vehicle, you can have a very expensive battery electric vehicle that gets you long distances, but it's more expensive and it has more robustness as a battery and so on and so forth. But if you were talking about standard vehicles, for example, then battery electric vehicles have much less range. It's a fraction, but not a low fraction. We're talking about maybe it has a 70% range differential.
Okay. Yeah. Big hesitation people have is safety, especially with high pressure storage. What do you want people to understand about hydrogen safety today versus the outdated Hindenburg fear narrative?
So generally speaking, we've had hydrogen transporting on our roads for the past 8 or 9 decades, and it's the issue of what happened with the Hindenburg, where hydrogen safety ended up becoming a really important focus, and a lot of energy, a lot of hydrogen safety elements have been put into place over these past decades that make it much more safe than even petroleum products. So if you had a fuel spill, for example, from the petroleum that you put in your car, for example, it's more likely to catch fire and explode than hydrogen would be. And the other thing that's really important about hydrogen is that when there's a hydrogen leak, the hydrogen goes directly up. It's such a light molecule. It's the lightest, smallest molecule in the universe. It goes straight up. And so the degree to which you have open air prevents you from having explosive sort of incidents.
Okay, so it's more likely if it's an open air environment to escape and not be explosive.
Yes, exactly. So, for example, with our on-site hydrogen fueling stations, when you approach the station, it looks like it's enclosed, but the top is open, and so that means the hydrogen has a place to escape if there's an incident.
Okay, so it's designed with that safety feature in mind specifically.
Absolutely. And
Yeah.
in the case of a tank on board a vehicle, which was the basis of your question, the tank is manufactured in such a way that there's such a thickness to the wall of that tank that it contains the hydrogen.
Hmm. Right.
And
Yeah.
there's safety elements in the manufacturing and construction of those pieces of equipment that prevent mishaps.
What would you say is the most misunderstood myth about hydrogen you find yourself correcting over and over?
In addition to the safety issue that we just spoke about, I think the other area is in the viability of hydrogen in terms of its cost effectiveness today. And a lot of people would say, well, it's too expensive to produce hydrogen, and it doesn't make sense for that reason. And then another reason people would say is, well, hang on a second. So you're going to use electricity to create hydrogen to then use it for electricity? Why don't you just use it as electricity and be done? Forget the hydrogen. And I
Uh-huh.
think the explanation to that is in certain situations when you need to have an energy storage mechanism for a period of time, then hydrogen is that storage mechanism. So, for example, in the middle of the day when you have a lot of sun, but nowhere to put that electricity that you create from a solar system, then what do you do with that energy? A lot of people would say, well, just let it go. You're never going to use it anyway. But another set of people would say, use it to store into hydrogen and store that hydrogen for a period of time until you need it at some future point. So
Mhm.
there are different ways of looking at it, I think.
Okay. You explained before when we spoke, hydrogen stations typically follow a compressed or dispensed delivery model, whereas PowerTap's differentiator is producing hydrogen on site from natural gas. What does that change in cost, logistics, reliability, and emissions?
Yeah, so there's a few areas. First of all, in the first instance, you think about the transport of hydrogen. If you have a compressed store dispense model where you take hydrogen deliveries, then of course that hydrogen has to be transported from somewhere, a central processing and production facility. In the
Right.
case of a power tap system, there is no transport. We're using the existing natural gas system to produce the hydrogen, uh, and that is readily available. So we eliminate the transport costs. And then there's another aspect, and that is how do you transport that hydrogen? You use a vehicle that's probably uh, has a significant carbon intensity. It's a diesel vehicle, for example. You eliminate that carbon intensity, which is a pretty significant impact to the environment. In terms of logistics, it's exactly along those lines. You're eliminating the transport, which is important. You also have reliability from the perspective that you can produce the hydrogen on an ongoing basis. You don't have to wait for the delivery of the hydrogen once you run out or anticipate the delivery of the hydrogen when you need it. And we talked about the emissions piece, but it's significant. Now, I just want to touch on one point relating to emissions. Our system is a blue hydrogen production system in the sense that its steam methane reformation takes natural gas and extracts the hydrogen, and you're left with carbon monoxide and carbon dioxide. We continue to add oxygen to it, and we take the CO2 and we capture it, and then we have off takers for that CO2, specifically dry ice makers. It's dry ice, and then there'll be many other uses for CO2 that we'll make sure to factor in as we go forward.
Oh, very cool. Okay, so you've already considered capturing that carbon in that process. So it's
Yeah.
already a sustainable model or product. Now, you've described this as a blue hydrogen solution, like you said, including carbon capture with off takers like dry ice and potentially SAF in the future. How do you think about the practical role of blue hydrogen in accelerating the transition while market matures?
Yeah, I mean, here's the really important thing is that blue hydrogen production is probably the most cost-effective emission-controlled process for producing hydrogen. And like I said, it's the most cost-effective. It's the green hydrogen production, which is taking water or any sort of renewable energy and producing that hydrogen from a source like water, for example, or it could be any sort of renewable product. And in this case, I'm thinking woody biomass, for example, is a product which is a challenge for us as an environment. And how do you manage that? So you, for example, gasify it and you create a syngas from which you extract hydrogen. That's not as cost effective a method as of yet, but it will be as we start to deploy more hydrogen systems. So green hydrogen production, primarily it's really done from water right now in the current environment. It's way
Mm.
more expensive, but again, over a period of time, that cost is going to come down as more systems are deployed and we have an economies of scale that we end up achieving.
Right. Yeah. You've taken technology from earlier generations and scaled production dramatically. What were the biggest engineering or deployment constraints you had to solve to get to a higher output footprint that can work at real fueling sites, especially in California?
So the engineering challenges were significant. Most hydrogen is produced in central production facilities that are fairly large scale. They produce 50 to 100 tons of hydrogen per day. Our systems are producing 1 to 8 tons of hydrogen per day. The most significant challenges with hydrogen are this is sort of an interesting effect. As you compress hydrogen, it heats up. As you decompress hydrogen, it heats up. So there's a significant challenge involved with that. And so there were certain methods that we needed to employ to manage those different issues. The other issue is that I mentioned that most hydrogen production systems are large scale. In tightening it up, you're producing hydrogen with components that are in a tighter space, and that was a significant challenge. And so there were certain things that we need to consider in that smaller footprint. And typically, there's a reason that hydrogen is produced in these large scale facilities because it's more costly to do it in the smaller footprint. But our technology, the way that we brought it together with the different elements, solves that problem. So
Yeah.
that was mostly what it had to do with. And it's significantly an issue in California because land use is more expensive. Land is more expensive. And so you'll see that most fuel stations are pretty small. So we
Hmm.
were able to get our 1,250 kilogram per day station. And I mentioned earlier that most fill ups for light duty vehicles is in the range of 6 to 8 kilograms, 6 kilograms or so. So that gives you a sense of how many vehicles you can accommodate with a 1,250 kilogram system. That system can fit in about a 1,600 square foot footprint, call it under 2,000 square feet. Where at a fuel station, it's still quite a bit of space, but you can do it in roughly about a third of the fuel stations that we've been able to factor in our system.
Okay. So it's the size hasn't been a constraint of your production.
We have to get it down to a point where it would work. And again, it doesn't fit at all existing fuel stations, maybe a third, depends on how you configure as well, though. I think one of the key aspects of a fuel station is you need a convenience store. And the hydrogen fueling station potentially takes out the convenience store. So
Oh,
you'd put it in the place of a car wash, for example.
right. Okay.
Just thinking about the mechanics of what it looks like at a fuel station.
Right, of where it's located. So can you retrofit existing stations with your
You can, and this
uh-huh.
is where our experience was that we fit in about a third of the situations of existing
Okay.
fuel stations out there today.
Just depending on how much land they have and the configuration of where things
Right,
are with each
exactly.
station. Okay, interesting. And it's above ground. Everything is above ground?
It is primarily above ground. There is our active hydrogen storage system, which has a subsurface component. It's a water tank that's subsurface that provides the offset pressure for the hydrogen storage system.
Okay, yeah, because I guess current fuel tanks are typically underground, at
Yes, right.
stations and
In
yeah, okay.
in our case, the hydrogen fuel tanks are above ground hydrogen fuel tanks.
Now, clean energy infrastructure isn't just technology, it's permitting, incentives, credit markets, and partnerships. How do you approach building in a world where policy and economics can change fast?
But it is challenging, there's no doubt. Like with many land uses, you don't snap a finger and it's constructed and manufactured and it's done. Right? There are those processes. So it's challenging to pull that together, but it's a matter of working with communities and trying to figure out what the future holds. Right. So it's challenging. In the case of a decarbonization effort that we're currently in globally, more so than here in the United States. It's looking down the path to see what you can improve that
Mhm.
really aligns visions. I was talking about alignment previously, and I think decarbonization is an area where, in most cases, you can align constituents with the policymakers in the manufacturing or the development of hydrogen fueling stations.
Yeah. And with your background and approval rate navigating entitlements, what's your playbook for getting difficult projects approved, especially when stakeholders have competing interests?
It goes back to the basic skills that I'd mentioned earlier, where the ability to bring different parties together, having flexibility, creativity on what is going to drive your product, your project in conjunction with the community. What is it that they want? And so there is that open mindedness that you have to have toward that. And again, you have to balance that with the economics and the financial aspects of the station and its future operations, but there has to be that level of flexibility. It's a little bit more straightforward with the production of hydrogen. There is a nuance in particular we're manufacturing hydrogen in essence at a fuel station, which is a unique uh, activity. Generally speaking, people are used to there's a delivery of fuel. My only participation is that I'm taking my little portion of that when I fill up at the station. So the manufacturing aspect is a little bit unique, but
Mhm.
it's a matter of communicating the safety of it. And then there are other aspects, right, in terms of fitting into a community. What's the noise factor? And our systems aren't noisy, which is important. And then, of course, there's the emissions aspect.
Right, yeah. As far as safety, is there, I mean, any difference in safety between
Yeah.
petrol and hydrogen?
There is, yeah. So there are requirements that the NFPA, for example, drives a lot of our hydrogen safety at fuel stations, and that's different for hydrogen than it would be for petroleum products. The reasons I mentioned earlier, hydrogen very light molecule goes straight up. petroleum pools on the ground and is flammable from that perspective. So they're just
Hmm.
different approaches. They're different, but there are systems in place in the United States in regulations such as the NFPA, for example, that drive those requirements.
Okay. Now, as hydrogen expands beyond early markets, what will determine winners? Technology, site strategy, partnerships, credit markets, or something else?
I think what's really important to be thinking about is that we have an all of the above strategy when it comes to energy. There shouldn't be one straight approach that applies across the board. A lot of people think that electrification is that one end all be all that works for every situation. And I don't think that's the case. We need to be open minded to thinking multiple forms of energy that can work. And I think that that similar mindset should work in terms of the kinds of partnerships you create, the credit arrangements you create. We need to be open minded and consider all possibilities. Tax credits is a really important area. And I think from a credit perspective, that makes sense for us to put tax credits in place for incentivization of such technologies as hydrogen. But that could apply for multiple energy opportunities or options. Yeah. So I think it's just an all of the above strategy, open-mindedness, creativity. And I think that's what's going to drive.
And at PowerTap, what is your main focus right now? What are you currently working on?
Our main focus is commercializing our third generation of technology so that we can start to deploy stations quickly. We do have a timeline ahead of us. The tax credit I mentioned a moment ago, that tax credit for hydrogen production requires us to start construction of our fuel stations by the end of 2027. So we've got
Okay.
a lot of work to do. Completion of the raising of our capital, the commercialization of our first station, and producing the technology in its final form, and then creating multiple fuel stations in relatively quick fashion along a corridor that makes sense. And part of the challenge there is we're a bit ahead of the game in terms of the vehicles, right? The hydrogen fuel cell electric trucks are not on the roads yet. There are some on the road, but from a company that went out of business, from two companies that went out of business recently, earlier this year. And we're getting ahead of it a little bit. The hydrogen fuel cell electric trucks that are expected to come on the market will come out at the end of the decade, so towards the end of 2028, 29 timeframe, and then going into the 2030s. So in a sense, it works out better because we'll have at least the framework of an infrastructure in place before those trucks come. And that would
Hmm.
be exactly what's required. You talk about a chicken and egg problem. That's exactly what
Right.
that is, right?
It sounds like it. Yeah, exactly. Now, finally, Salim, for leaders building in energy, real estate, or infrastructure, what's one mindset shift you think is essential to thrive in the next decade of industrial transformation?
I think it's what I mentioned earlier. It's an all of the above approach that encourages creativity and the acceptance of new technologies. Certainly, it's not picking winners and losers early on. It's being open minded to a broad number of solutions, and I think that's the mind shift we have to be thinking of. Not just to focus on pure electrification. That's definitely going to solve a big piece of the puzzle, but it's just being open to all sources of energy. I think that's really
Right. Yeah, I like that. Yeah, good. Just keeping open-minded, keeping options open, and continuing to educate, I think, yourselves too, because things
absolutely.
things technology changes so quickly, and not only technology here, but abroad around the world. So keeping up to date on what's happening all over. Yeah. Well, Salim, thank you for breaking down this so clearly and for the work that you're doing to move clean energy from concept to real world infrastructure. Very exciting. I look forward to following you in the next couple of years to see PowerTap hydrogen fueling stations popping up all over the place. Now, for listeners who want to learn more about PowerTap Hydrogen Fueling Corp, where's the best place to connect with you online?
Probably the best place is our website at powertapfuels.com.
And to everyone listening, if you enjoyed this conversation, please subscribe, share this episode with a friend, and tune in to the next episode of Industry Ignited. Until next time, stay bold, stay curious, and keep igniting industry.